and then we'll do the problems. Hello and welcome back to the last portion of Calc 1. We are going to take a look at final exam. So we have chapters 2, 3, 4, and 5. And we are covering all three concepts on the final. So limits, derivatives, and integrals. Now, what I have is the list of the most important things that are definitely going to be there, 100%, no question asked, right? 2.3, 2.4, 2.5. From chapter 3, we are looking into the 3, 4. I can't recall all the sections. You know, I'm going to switch from here into titles. So basic derivatives, product plus quotient, and then we have chain rule, and then we have implicit, and then we have logarithmic, then I have implicit, logarithmic, then I have related rates, then we already in chapter 4 we have min-max, first plus second derivative test, that could be one problem. Just do the first and second derivative test of something that you can do quickly. Graphing functions. That was 4.3, right? But I'll give you everything. You just draw. So graph functions. Word problems, min-max. So min-max, and I'll put here on top, and word problems. That's 4.4. Linearization. No coughing. And differentials. We have integrals. Oh, L'Hopital's rule. Ho 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 ho. L'Hopital's rule. And now we go integrals. I'll put in some basic, meaning 4.9. Definite integrals. That's 5.2. Fundamental theorem of calculus is a learning outcome, 5.3. And 5.5 U sub. I just realized that I did not do this, so I will do it now. That's too much. That's too little. There we go. Tangent line. So you are going to have a tangent line problem that will have one of these derivatives. If you recall your exam 2, your tangent line problem had implicit differentiation. So take a look at that. Take a look at taking the first and the second derivative consecutively. Take a look at combining rules, chain rule, within the product rule, and then maybe you can do it either regular way or you do it with logarithmic differentiation if you learned that powerful technique. Related rates word problem must be there. 4.4 optimization problem, min-max, must be there. Probably differential or word problem, maybe mean value theorem or something, some of the word problems. So just take a look at all of the word problems we had. Problems that are definitely not going to be there are working out the derivative using the limit, because, I mean, this is not honors section, so we are not going to have proofs on this exam. We are not going to have the limit definition from 2.7 to calculate problems. We didn't do that even for homework. We're not going to have the limit with the difference quotient. We are not going to have the Riemann integral with the sum thing that we did, you know, each problem 15 minutes. I mean, there is enough material over here. This is more, you know, computation than proofs and things like that. I mean, in terms of this class. What else? What else? What else? So that's the list of things. Make sure you can integrate. Make sure that your indefinite integrals from 4.9 have plus c. Make sure that your definite integrals do not have plus c. They need to have just an answer. Is there anything else? I said 12 to 15 problems, 2 hours, right, in this room. And each other page on the exam will be blank, so you can use it to do extra work or put some artwork that I would appreciate. If you are handing anything in, just put everything on a desk in separate piles. So you have a pile for projects and a separate for the labs and whatever else. Homework, class preps, tapes. What else? I don't think I have anything else. What? I was kidding. Obviously all. But that should be obvious, but then I'm joking. You know?
My girl, he studied that. I was with the Tuesday, Thursday class.
The organic?
No, I was talking about study for Cal.
Oh.
I was realizing.
Okay, good.
So there aren't going to be any like quizzes?
No. Final exam is final exam, no tempering. Any other questions, concerns?
You said that a lot of it is going to be like that.
Well, you are going to have one problem that will have U sub, and there are two U sub, so at least one problem A and B, which is U sub, so one with definite and one with indefinite, right? So one you have to change the limits as well and compute. Then you have fundamental theorem of calculus, which is the learning outcome. So here's the one problem A, B. Here's just one, so let's say that's problem number 1, this is problem number 2. And then basic integrals combine this into another problem with maybe A and B. So you're talking 3 problems, but actually 5 problems, right? You can think of it that way. So that's your chapter 5 right there. Yeah, I know integrals 4.9, but it's integrals. So let me put integration. So, you know, with A and B, this could be a good 25%, 30% of the exam. Which, I mean, right, if we are to do it justice, 33.33%, right, on limits, and 33.33% on derivatives, and then 33.33% on integrals. But then, again, mainly this course is on derivatives. Mainly, because, right, that's more than half of the sections are derivatives related. Way more than half, like 3/4 maybe even. Any other questions, concerns, any problems that you would like me to work out? Or we're going to call it a day. Yes? The answer is yes. I have no clue what it is. No, just say it.
Well, it's a numeric theorem, and the function is f of x equals 3 sine 2x interval 0 pi over 4.
Perfect. Mean value theorem states that if function is continuous and differentiable on interval a to b, you are going to have at least one point c where the average of the function is equal to instantaneous value of the function. So instantaneous value is f prime at c is equal to f of b minus f of a divided by b minus a. So now I see that I need the derivative for the left-hand side of the formula. So y prime is going to be 6 cosine 2x. Right, 6 cosine 2x. And I need to replace x with c when I plug that in where the derivative goes in the formula. So now to put everything together, 6 cosine 2c is equal to 3 sine 2 times pi over 4 minus 3 sine 2 times 0 divided by pi over 4 minus 0. As you can see, the only unknown variable here is c. So we just need to solve for c and we are done. All right, let's do it. We have 6 cosine 2c is equal to 3 sine, and then this is pi over 2 minus 0 divided by pi over 4, because sine of 0 is 0. Now sine of pi over 2 is 1, so I have 6 cosine 2c is equal to 3 divided by pi over 4. 6 cosine 2c is equal to 12 over pi. Multiply both sides by 1 over 6 to start, getting at c. And we get that the cosine 2c is equal to 2 over pi. Hit both sides with the inverse cosine to get c alone. And we get 2c is equal to the inverse cosine of 2 over pi. And just multiply by 1/2 to get c alone. So 1/2 cosine inverse of 2 over pi. Now if you set your calculator to radians and then you can compute and get the decimal, no one cares. This is the exact value of the point C where average and instantaneous values are the same. Bueno, so that's problem number 2b for mean value theorem. Anything else? Exams 1, 2, 3. Homework. No labs and no projects because you haven't handed those in yet. So. Yes? I can. What is it? The open box problem. Good. So, if you observe around you, you are currently in a box. Box has 6 sides. Now, if we take the ceiling off, the box will have 5 sides. The box that you were supposed to consider is the box that has 5 sides, no top, and it has a square base. That means that the wall where the board is and the wall where the windows are the same length, and the height is a different length. So if I am to draw that, I will label the sides on the bottom XX, and the one on the top I will label Y. Volume is area of the base, which is x squared, times the height, which is y, and that is to be 125 something cubed, meters cubed, whatever. And that's my constraint equation. I would like to minimize surface area. And this is why it's important to know that there is no top. Because the area is the sum of all areas for every individual side. You have on the bottom x squared. You see, no top. If there was a top, you would have one on the ceiling as well, and it would be 2x squared. But because it's only one on the bottom, you have x squared, and you have plus 4xy's. Those are the sides, like where the wall is, where the board and the windows and door and the green wall in the back, right? Those are all x times y. And we want that to be minimum. So here are my two equations, right? I have my two equations here. So now I solve in the top equation, I solve for y, which is 125 over x squared, and I plug that in. So now x squared plus 4x, and instead of y I have 125 over x squared equals the minimum. X and x will cancel. 4 times 125 is 500. So it's x squared plus 500 over x equals the minimum. So we are at the point where we have the most simplified equation, which only has one variable, and we are ready to use the derivative on it. So we hit this with the derivative dx, and that will give us 2x minus 500 over x squared is equal to 0. Derivative of minimum is 0. Because remember, minimum represents some minimum area. Let's say it's 25. Derivative of 25 would be 0. Whatever that number is. We don't know what the minimum number is, but we know it's a number, and when you take the derivative of it, it becomes 0. You learned this type of the thing in 4.1 when we say set the derivative equal to 0. Well, now we get it from the concept, right? Move 500 to the other side. We have 2x is equal to 500 over x squared, from where x cubed, why when you cross multiply, and then divide by 2 is 250. So at this point, we have that x is equal to the cube root of 250. 250 can be written by 2 times 125. So it's 5 cube root of 2. 5 cube root of 2 are your x dimensions. Now you can go and get the decimal if you're interested. So now when I start writing my answer, it's 5 cube root of 2 by 5 cube root of 2 by, and I need the height. So for that, I'm going to go back to the y equation, which is 125 over x squared. 125 over x squared. So 5 cube root of 2 squared. When you square this, you get 125 over 25, and then you have times 2 to the 2/3. That's 5 over cube root of 4. That's what it is. So y equals 5 divided by, to get the cube root of 4 over here, I need to multiply by cube root of 16 to rationalize. Because that will give you 64, and cube root of 64 is 4. So what I have is 5 cube root of 16 on top, divided by cube root of 64, which gives me 4. So 5/4 cube root of 16. I'll write this better. So I have the dimensions. Now this is exact. You can go and find decimals if you're interested. It's 5 cube root of 2 by 5 cube root of 2 by 5/4 cube root of 16. Oh wait, 16, we can deal with that. Sorry. That's 2 times 8. So it's actually 5/2 cube root of 2. There we go. Much better. So those are the dimensions of a box. Now if you multiply this through, you see that it works. 5 times 5 times 5 is 125 over 2. And then you have root 3 over 2, root 3 over 2, root 3 over 2. That's root 3 over 2 cubed. These guys cancel. And you have 2's cancel. And you have 125. So it's good. We know that it's correct. So dimensions of the box are 5 cube root of 2 and 5 cube root of 2 and 5. After the class, you probably want to say I have that and I mark you wrong.
Yeah.
See, I read minds. Anything else? Yes. Yeah, out of all problems on the exam, that was my least favorite one. I don't know. I'm probably going to retire ln with the linearization when you have to. I don't know. I'll come up probably with something else for linearization. I use trig. It's like everything is equally awful. Right? Unless you lose a polynomial, but then what's the purpose of it, right? You can compute polynomials, so who cares? Anyway, so linearize f of x equals, was e to the x? E to the negative x. At a equal ln of 2. Yeah. So, when would something like this arise? If you are using e to the negative x to compute, let's say x equals 0.8, for instance, then linearization would help. Other than that, you have the calculator, so linearization doesn't matter anymore. But anyway, we are going to find the derivative, and that's negative e to the negative x. Now, linearization formula, you can do the tangent line, is f of a plus f prime of a times x minus a. Now, your a is ln 2. So let's go. L of x is equal to function computed at a, that's e to the negative ln a, plus the derivative computed at this. So this is negative e to the ln a, negative ln a, sorry, times x minus ln 2. Now, the negative over here, sorry, not ln a, ln 2. What am I talking about? ln 2. A is ln 2. Much better. Okay. So, compute e to the ln 2. So I know that this negative can jump inside, and I have e to the ln of 1/2 minus e to the ln of 1/2 times x minus ln 2. So what I did is I took this negative ln 2, wrote it as a negative 1 ln 2, used the rule to move this negative 1 as the exponent, and then wrote it as the 1/2. That's what happened when I look at these things. So those are all the steps that you can possibly think of to write as you transform this into the next one. Now, why do I want to transform it? I want to transform it because e and ln cancel. So now L of x is 1/2 minus 1/2 x minus ln 2. And now, you know, you could possibly check out right there. But then, you know, it's really not a mx plus b form. This is already linearized. The problem could be over right there. But then you can also go an extra step to get, you know, x alone and first, and get all the other numbers and constants at the other end, so it looks like mx plus b. So L is equal to, and now I have 1/2 minus 1/2 x plus 1/2 ln 2. And now we write negative 1/2 x first, and then we have plus 1/2 and plus 1/2 ln 2. This is also where you can end, because now you have your mx plus b, right? So you can stop there. But you don't have to. You can just factor out 1/2 now in front, and then just have negative x plus 1 plus ln 2. Right? If you factor out this. Whatever form you have, so everything you see on this, every line is okay to have. Maybe you can have also negative 1/2 x plus 1/2 in parentheses 1 plus ln 2. There we go. So that one is even more of y equal mx plus b, because you have your m, your x plus b as a number. So that's that. Now, if you are to take any of these over here and plug in 0.8 or let's say 1, whatever is close, right, to 0.8, if you plug in those values for x in any of these, and then you compute e to the negative, let's say 0.8, you are going to get two numbers that are very close, because this linearizes around ln 2. So any number that is sufficiently close to value of ln 2 will be good number to compute in linearization, because its y value and the function's y value are close. Anything else? Problems? Exams 1, 2, 3. Yes. Use differentials to approximate rule 98. So now, when you're looking at this square root of 98, that gives you the function square root of x, and your value a that you can compute without anything is 100. Your dx, which is the delta x, is 98 minus 100, which is negative 2. So now, the differential dy is the derivative times dx. Well, the derivative is 1 over 2 square root of x, so we'll put 100 there, times negative 2. So if you can see, the 2 and 2 cancel, you get negative 1 over 10. And that's negative 0.1. So now, square root of 98 is equal to the square root of 100 minus dy. Well, that's 10 minus 0.1, which is 9.9. Three lines. Oh, I should put approximate over here. Put the approximate. Put the approximate right there. Board. Any other questions? Because yes.
Can you do
Oh, I can.
the integral of parentheses 2 over t minus e to t parentheses e to t.
Okay. So the integral on the first one is actually integral of 2 times 1 over t dt minus the second integral e to the t dt. So I separate the integrals in two. You don't have to. Now you kick the 2 outside as a constant. And you have 1 over t dt minus integral of e to the t dt. So now we can actually do this integration. Copy 2. And what's integral of 1 over t? ln of absolute value. Very good. ln of absolute value of t minus e to the t plus c, and we call it a day there. Okay? Any other questions? Exam 1, 2, 3. Yes.
Can you do integral for limit of x approaches negative infinity for x sine 1 over x?
We can do this in two different ways. Let's see. So we start with test first over here, and we see it's infinity times 0. It's infinity times 0 because when you plug in infinity in x, you get infinity. 1 over infinity is 0, and sine of 0 is 0, so this is infinity times 0. Now, when you have infinity times 0, that tells you that you should be using 1 over f. That's the standard thing. So now limit x goes to negative infinity. Sine 1 over x divided by 1 over x. And if you check now, you have 1 over x is 1 over infinity, which is 0. So you have 0 over 0. Great. So now I have 0 over 0. This means that I can unleash L'Hopital's rule. L'Hopital's rule is taking independent derivatives, not a quotient rule. Independent derivatives, and then hopefully we'll be able to plug in and solve. So limit x goes to negative infinity. And now the derivative of sine is cosine 1 over x times the chain of negative 1 over x squared. divided by negative 1 over x squared in denominator. Now these guys completely drop because they're identical. And now you just have integral of 1 over cosine. Sorry, integral of cosine 1 over x. So when you plug in infinity for x, you get 1 over infinity, which is 0. And cosine of 0 is 1. There's a much cooler way to do this problem. And that cooler way is, or limit x sine 1 over x. X goes to negative infinity. So I can bet that when you look at this problem, you say, really? Sine of 1 over x? Really? Right? The rest of the problem should be fine. But it's that sine of 1 over x that's bothering you. We just learned the technique in this class of what you should do with expressions or people that bother you, right? We use u substitution, right? So u equals 1 over x, and we don't take derivatives or anything. It's just a straight up substitution. So what's x? In that case, x is 1 over u, right? Implies that. So now, limit. So if x goes to infinity in your substitution, where's u going? 0. So this is u goes to 0 of 1 over u sine u. Or to write it in the terms that you have seen it earlier in the class, sine u over u. You had this as sine x over x, and you know the answer for that is 1. You had to memorize this at one point in time. Now you can also take derivatives. This cosine of u over 1. 1 over 1 is 1. So this is far cooler way to do the same problem. We used u sub, but we didn't do the derivatives in other part because we don't have dx to replace as well. So we didn't have to go and do the derivative part of the substitution. We just did the function part of substitution. So that's that. Anything else? Exams 1, 2, 3. So. Did you just draw it? Yeah. Oh, it's an iPhone. No. Anything else? Yes.
On exam 1, limit as t approaches 49, t minus 49 over square root of t minus 7.
All right. So this problem can be solved in two ways. You can either rationalize, right? You multiply top and bottom by root t plus 7, root t plus 7, or you can use that cute trick to factor the numerator. So when you factor the numerator, you will get square root of t minus square root of 49 times square root of t plus square root of 49. If you factor square root of t minus 7. Now square root of 49 is 7, so I'm just going to replace those with 7s. And now you see that these guys cancel, and all it's left is the limit t goes to 49 of square root of t plus 7. 14, right? because when you plug in 49, square root of 49 is 7, 7 plus 7 is 14, and that's that. So that would be one of the ways. Another way would be to multiply by root t plus 7. Root t plus 7, when you FOIL the bottom, it will cancel with this. There will be 4t plus root t plus 7 stay, which is this one, and it's the same way. I mean, same solution, different way. Any other questions, concerns? It's the same, factoring. So you have the limit x squared minus b squared over x minus b, where x goes to b. So this is technically a repeat of the first question. You factor the top, you cancel, and then you plug in b. So answer is 2b. We had 2 times 7 is 14. Now we'll have 2 times b is 2b. So x goes to b. X minus b, x plus b. 1 year I put in a cubes there. And 1 student in the entire classroom of 30 knew how to factor a cube. It's algebra. So when you plug in b, b plus b is 2b. Any other questions? Do you have any questions? Full. Okay. We should probably do it. So we did this one and this one. So this one. Oh yeah, they don't go there. Yeah. It's a notation issue. Any other questions? Exam 1, 2, 3, or homework, or concept, or a problem? So we're done with the semester? Because then it's over. You see, actually, Walter just snatched his lecture. That would be bad. Yes?
Find the inverse function of f of x equals...
That's pre-calculus.
Yeah.
So, yeah. Well, what I'm saying is not going to be on the test, but you swap x and a y, so write it as not f of x, but y equals that, and then you swap x and a y, and then you just solve. So write it now, x equals y plus 5, everything cubed, and now start cube root and all of that to get y alone. Anything else?
Go over the one is asymptote. It's fx equals 2x squared divided x squared minus 1.
So for this we have the asymptotes and the first derivative test. So we have 2 vertical asymptotes at +1 and -1. That's what we have. Then we have 1 horizontal asymptote at y equals to 2 because the exponents are the same. So we take front coefficients. 2 divided by 1 is 2. Slant asymptotes, none. So you have to state all 3 of these because it said find all asymptotes. Right? Slant asymptotes we don't have, so we just write there are none. Then we take the derivative because we are supposed to do the first derivative test. You can do logarithmic differentiation or you can do the quotient rule. In the quotient rule, we have x squared minus 1 square, x squared minus 1 over here, times the derivative, which is 4x, minus 2x squared times the derivative of the denominator is 2x. When we FOIL everything and distribute everything in the numerator, we get 4x cubed minus, on 2 or 3 exams, students put just 4 when it's 4x. It's 1 times 4x, you get 4x there. And then minus 4x cubed over x squared minus 1 squared. These cancel, and now you have your first derivative to be negative 4x over x squared plus 1 everything squared. When you set that equal to 0 to find your critical points, when you cross multiply, denominator goes away, and all you have to consider is 4x equal to 0. Divide both sides by negative 4, x equals 0, and when you plug that in original equation, you get y equals 0, so 0, 0, critical point. So now you know your critical point, and here is the first derivative test now. Many of you had the issue with this. You have your critical point for partitioning at 0, but you also have 2 asymptotes. There is a reason why I asked you to figure out asymptotes as well, because you have to partition on those asymptotes as well. So I have a critical point, I have the vertical asymptote here and the vertical asymptote here. Now the test points, what are the test points? Negative 2, negative 1/2, positive 1/2, and positive 2. So those are my test points, and then I do the first derivative test using these 4 test points. Now, depending on your level of math involvement, right, you know that we only care about whether the value of the derivative is positive or negative. You also know the denominator is squared, which means it's always positive no matter what you plug in. So technically, the sign of the numerator is the sole predictor on whether it's decreasing or increasing. Again, this is squared, so it's always positive. If you divide negative by positive, you get negative. If you divide positive by positive, you get positive. So whatever is here is the sign, and then that's going to be positive or negative. So all I need to do is to figure out the first derivative at negative 2, but I only need to worry about negative 4 times negative 2, and that's increasing. First derivative at negative 1/2, it's negative 4 times negative 1/2. That's also larger than 0, goes up. First derivative at positive 1/2 is going to be negative 4 times positive 1/2, which is negative 2, which is decreasing. And the last one, the first derivative at 2, is negative 4 times 2, which is negative 8. It's also decreasing, telling us that this point here is a max. And that's the complete problem. So you do the vertical asymptotes, horizontal asymptote, slant asymptote. That should take about 17 seconds with writing. Then the derivative, let's say a minute or 2, carefully. Solve the equation, another minute. There are the test points, so you should be able to do this in about 8 minutes or so, 7-8 minutes for this problem. Anything else? Exams 1, 2, 3. Is that a request?
No.
I might put definition of a function.
How about logarithmic differentiation?
How about it? It's on the list. Why not? So if you have there it is. Oh, it's glory. Questions, concerns, anything?
Can you do one of those?
Sure. Which one? We have a logarithmic differentiation coming in.
There's none of the test.
Yeah, there is. Test 2.
Oh, so that's equals x squared parentheses sin x over.
Yes, that one. The fourth root?
Yeah, 4 root x minus 1.
All right. So, so I'm going to do the whole procedure and then I will talk about the shortcut at the end. So the procedure is to replace f of x with y and then ln both sides, which will get you to expand everything. So 2 ln x plus ln sine x minus 1/4 ln x minus 1. And then once you expand everything, then you do the derivative. So now we do the derivative, right? When you take derivative of y in respect to x, follow with the chain. On the right hand side, we get 2 times 1 over x plus ln. You put the function on the bottom and its derivative on top, which is cosine x. Dx alone. So y times 2 over x plus cotangent x minus 1. So y is x squared sine x over the 4th root of x minus 1 times 2 over x plus cotangent x minus 1 over 4x minus 1. And that will be the answer. Now for the shortcut, you can remember that this is... Now the stream failed, so maybe some of this stuff is not on the video. I'll have to post the notes. Anything else? Going on once and twice and That's the end of the Calc 1. Yay! You lived. See you all Tuesday.